Good morning. Today's topic is DC generator. Normally, electrical machines deals with transfer of energy from one form to the another form. Electrical machine which converts mechanical energy into electrical energy is called as electric generator. In this session, we'll discuss about DC generators, principle of operation, construction of DC generator, and the working principle of the DC generator. As explained earlier, DC generator is nothing but converting mechanical energy into electrical energy. Normally, DC machines are classified into two types, DC generators and DC motors. Here, the DC generator is converting mechanical to electrical energy, and DC motors are converting electrical energy to mechanical energy. Principle of operation. It works on the principle of Faraday's law of electromagnetic induction. According to this law, when the conductor is rotated in the magnetic field to cut the magnetic lines of flux, induced EMF is produced in the conductor. This EMF causes a current to flow if the conductor circuit is closed. Faraday's law. There are two laws, first law and second law. Faraday's first law states that whenever the conductor cuts the magnetic flux, EMF is induced in that conductor. Second law states the magnitude of the induced EMF is equal to the rate of the change of the flux linkages. Faraday's law of electromagnetic induction. That is, it states that changing a magnetic flux through a loop or loops of wire induces an electromotive force or voltage in each loop. Fleming's right hand rule. Fleming's right hand rule is used to find the direction of the current. Here, thumb represents the direction of the motion of the conductor. The first finger or the forefinger represents the field. The middle finger represents the current. The direction of the current is identified by using the Fleming's right hand rule. Requirements for generation of EMF or uniform magnetic field, system of conductors, relative motion between the magnetic field and the conductor. The magnetic field may be permanent magnet or electromagnet, and the system of conductors or coils used are copper or aluminium bars placed in the slot cut around the periphery of the cylindrical rotor. And relative motion can be obtained by prime mover, turbine or IC engines. Construction of DC generator. The diagram shows that the main parts of the DC generator and the construction is displayed. The cross-sectional view is displayed here. The important parts of the DC generators are yoke, poles, field winding, armature, commutator, brushes, gear and bearings. Yoke, pole and field windings are the parts of the stator, and armature, commutator, brushes, gear and bearings are the parts of rotor. Yoke is also called as frame. It provides protection to the rotating and the other parts of the machine from moisture, dust, etc. Yoke is an iron body which provides the path for flux. It provides mechanical support for the poles. Materials used for yoke are cast iron, silicon steel, cast steel, rolled steel, etc. That is, yoke is overall a outer part of the machine. Pole is nothing but it produces magnetic flux when the field winding is excited. Materials used for pole is cast steel or cast iron. Pole is a part on which the field winding is wound are over. Field winding is also called as the exciting winding. Current is passed through the field winding in a specific direction to magnetize the pole. The metal used for the field conductor is copper. Armature core. All these slots are parallel to the shaft axis. Armature conductors are placed in these slots. Armature core provides low reluctance path to the flux produced by the field winding. Cast steel or cast iron are used for the armature core. Commutator converts the alternating EMF generated internally in the DC voltage. It collects the current from armature conductors and passes it to the external load via brush. A rotor is a moving part of the DC generator. The rotor rotates because the wires and the magnetic field of the motor are arranged so that a torque is developed about the rotor's axis. Working of the DC generator. Working of DC generator. Here the DC generator converts mechanical energy into electrical energy. This is said already. In this DC generator, the single turn alternator is used. The coil can rotate in clockwise or anti-clockwise direction and the commutator brush is connected to the coil. Then the commutator is divided into two parts, part A and part B. Segment A and segment B. The coil is suspended between the field poles. Then the coil is given the magnetic energy which results in the rotation of it. As the commutator segments A and B is connected with the conducting coils A, B and C, D respectively, they rotate together, due to which the flux is produced, resulting in the generation of the electric current. As the commutator has a property of converting the bidirectional EMF into unidirectional EMF, that is AC to DC, then the DC current is generated by the DC generator, which can directly used by connecting the output across the load, or it can be stored in batteries and can be used later on. Next one is generation of AC voltage. And so the figure shows the movement of the coil, that is position the coil is moving where the coil is moving from the position A to A, that is A, B, C, D and again A in a circular motion. So it returns to the same position, then it return back to the same position. If the coil is rotating, if the coil is rotating, EMF is generated by the rotation of that coil. In the figure, A, B, C and D is used to describe the position of the coil. When the coil is stationary, there is no EMF produced. When the coil rotates at 90 degree, that is in figure B, the flux is generated, resulting in the AC voltage at the output. So the figure in figure B, the coil is in 90 degree the coil position is in 90 degree. So according to that, waveform is generated here. So the position in the output, the position B has 90 degree voltage, that is voltage is produced, and at the when the coil reaches at C, the half cycle of the rotation is completed. When the coil rotates further, another half cycle of the sine wave is generated. The efficiency of the DC generator can be increased by combining two or more number of coils at the same time, which will result in attaining 360 degrees at only one rotation of the coil. So according to the position of the coil, the waveform is generated. And in the figure A, the position is 0 degree. So here signal is at 0 degree. That is the starting point of the signal. Then in figure B, the position is 90 degree. The signal obtained is the signal obtained is uh, at, at the B position. The signal is at peak value. And in the figure B, in figure C, the position is 180 degree. The signal goes to 0. In figure D, the position is 270 degree. The signal gets inversed. Then again at the and again at the 360-degree position, that is, um, the coil comes to the original original position, that is A position. So the signal reaches 0. So we are getting a sine wave, which is an output of the DC generator. Thank you.